we're going to look at two examples of solving systems with three variables in them. All right, and just a quick recap, right? What are we doing? We're trying to find the ordered triple, the x, y, and z values that satisfy all three equations in the system, right? And graphically, that is the point where these three planes intersect. All right, one thing I want to mention before we begin, organization is going to be key. I want you to really organize your paper the same exact way that I'm doing it here. So first thing, let's label our equations. Right? I'm going to call the first equation equation A. I'm going to call the second one equation B. And the third one I'm going to call equation C. That way you'll know exactly which equations I'm referring to. All right, so we have equations A, B, and C. And I want you to think about which equation is the most useful to us right now. Which equation is the most useful to us? Right? And it's not A. A has three unknowns, three variables. And I can't really solve for x, for example, if I don't know what y or z is. All right? Well, B has two variables in it. Right? A little bit better, but again, I can't really solve for x if I don't know what the value of y. And same thing, I can't solve for y and get a value if I don't know the exact value of x. C is the most useful for us right now. Right? So I'm going to start with equation C. Right? C is the equation 5x equals 20. Why is this the most useful? Well, I only have one unknown. Right? So if I only have one unknown, I can really easily solve this equation. Right? I can just divide both sides by 5, and I found out my x value. My x value is 4. Right? So I already have one part of our ordered triple. Right? Well, what am I going to do next? Right, where can I substitute this in that will be helpful? Well, I'm not going to substitute this into equation A, because even if I know the x value, well, I can't find out y or z because I still have, there's two unknowns here. Right? I wouldn't be able to find out z, for example, even though I know x because I don't know y. I'm going to do a substitution with this value of 4 into equation B, right? Because that only has two unknowns. Right? Well, equation B said 2x minus 3y is equal to negative 7. Now I know the value of x. So let's replace x with 4. And we should be able to solve for y. Right? So x is 4. And then let's see what we get. We get 8 minus 3y is equal to negative 7. Right? Let's go ahead and solve this. Let's subtract 8 from both sides. That gives me negative 3y is equal to negative 15. And then to solve this, divide by negative 3 on both sides, and we get y is equal to 5. All right, so now I know my x value, my y, and my y value. And all that's left is to figure out my z value. Right? So now what am I going to do? Well, I can now use equation A. Right? Equation A had three unknowns. But if I know x, and if I know y, then I should be able to solve for z. So we're going to use equation equation A. Right? Equation A was this. 3x minus y plus 4z is equal to negative 5. Right? Let me write that again here. So we need a z. All right? And actually, I want you to do this. I want you to go ahead and pause and do a substitution, replace x with 4, replace y with 5, and then solve for z. All right, welcome back. Here's what you should have. So we're going to replace x and y, and then solve for z. So x was 4, y was 5. So let's see what we get. We get 12 minus 5 plus 4z equals negative 5. 12 minus 5 is 7. So 7 plus 4z equals negative 5. Well, here I can subtract 7 from both sides. And I have 4z is equal to negative 12. Right? And I'm going to divide both sides by 4. We get z is equal to negative 3. Right? And there we've done it. We have solved for our system, and our answer is the ordered pair 4, 5, negative 3. Right, that's our ordered triple. All right, we're going to solve another one. All right, and again, let's keep ourselves organized. Let's label our equation. So the first one, let's label that equation A. The second one is equation B, and the third one, equation C. All right, so let's think about this before we begin. All right, equation A, if I look at this, has 2 unknowns. Equation B has 3 unknowns, and equation C has, again, 2 unknowns. All right, and remember what we've been kind of saying. In order to solve for one of the variables, let's say x, you really need to have an equation that only has one unknown in it. All right, so our strategy in doing these is really to try to get an equation that only has one unknown in it. Right? Well, and here's how we're going to do that. If you look at equation A and C, hopefully what you notice is that they have 2 unknowns in it, but not only that, they have the same unknowns. In A and C, they both have just an x and a z in it. All right, let me write those 2 equations next to each other, and hopefully you'll see kind of what I'm getting at. All right, equation A was this: 4x minus 3z equals 9. And equation C is negative 7x plus 6z equals negative 12. All right, and think about that. Do we know how to work with 2 equations with 2 unknowns? Right, and the answer is yes. We've been using substitution and elimination, right, to solve these things. So if we had 2 equations, right, we would be able to, 2 equations with the same 2 unknowns in it, we would be able to create a new equation that just has 1 unknown in it. Right, and we're going to do that with elimination. Right? So we're just going to use our normal technique of elimination to solve this. All right, so here's what we're going to do. Let's try to eliminate a variable. All right, well, I noticed that right here, we can eliminate the z's pretty easily. Right, so what I'm going to do is I'm going to multiply the equation A by 2. All right, let's see what we get. That would give me, let me get some more room. That would give me 8x minus 6z is equal to 18. And then let's just rewrite equation C. It's negative 7x plus 6z is equal to negative 12. Right? And if we add these 2 equations together, these z's will eliminate. Right? We will have x plus 0 equals 6. Or in other words, x is equal to 6. All right, and now that we know x, let's think about how we can get y. Right? Where would I substitute this? Well, I need to substitute this into one of our equations that only has 2 variables in it. Right? And at this point, you can really choose either one. You can either use A or you can use C. It doesn't matter. Right? But again, I'm going to do that because those only have 2 variables in it. All right, let me use, how about equation A? So equation A, let's say we're going to use equation A here. This is 4x minus 3z equals 9. And I'm going to replace x with 6. So 4 times 6 minus 3z is equal to 9. That gives me 24 minus 3z is equal to 9. All right, and we can solve this. All right, let's go ahead and subtract 24 from both sides. All right, that gives me negative 3z is equal to negative 15. And then if I divide both sides by negative 3, I get a z value of positive 5. All right, so I've found my x value and my z value. All right, you go ahead and find the y value. Think about where you would do a substitution to find the y. Go ahead and pause and do that. All right, what you should have done is you should have replaced or substituted 6 and 5, the x and z value, into equation B. Right, equation B was this: x minus 5y minus 4z is equal to negative 4. Right, let's go ahead and finish this up. So our x value was 6, and then we have minus 5y minus 4 times my z value, which was 5, equals negative 4. Right? So we have 6 minus 5y minus 20 is equal to negative 4. If I combine like terms on the left, I have negative 5y minus 14 is equal to negative 4. Let's keep on solving. I'm going to add 14 to both sides. And I get negative 5y is equal to 10. And if I divide both sides by negative 5, I get my y value equal to negative 2. Right? And there we have it. We have solved our system, and our answer is the ordered triple 6, negative 2, 5. My x value, my y value, and then my z value.